Hey, do you need me to send you the link or are you good? Okay. Let me just 2 seconds. There we go. All right, you should have it. I just did. I always struggle to find your email because I keep typing in Paige and I forget that that's not actually your name. Well, it is, but it's not, you know?
Yeah.
Right. Would you prefer to go by that than Ken?
Actually, usually, if it's like, usually it's by now.
Yeah.
Well, probably because of Austin.
Oh, that's true. on Facebook. Live on Facebook. All right, we're going live. Hi, everyone. My name is Jennifer. I am from the New Haven Free Public Library. Thank you so much for joining us today. If you are on Facebook land, if you are on Zoom, thank you for joining us there as well. We are in the middle of our last Learn to Code series with Paige. I'm super excited to be doing this series. Paige is working on coding some graphics with us, which I think is really fun. If you have any questions, please feel free to put them in the comments. If you're on Zoom, in the chat, if you're on Facebook, I will be monitoring both. And I will also put a bunch of links in the chat and in the comments for Paige's office hours, as well as the link for the GitHub that Paige is going to be working from. You good, Paige?
Yeah, I think so. Yeah.
All right.
Okay, great. Yeah. That'll be okay for now. Okay. This is Paige from the library, coming to you live from the library, in person. So if you happen to see this on the stream and you want to pop down to the library for the next hour, feel free to do so, because I will be here. Okay, so just to recap, can you see my screen, Jennifer?
Yes.
Okay, great, perfect. So basically, this is the hub for all things computer graphics at the New Haven Free Public Library. This is a GitHub page. So you can go here and look at all of the session notes. They're just dated. So today's session is going to be under May 12th. If we hop into there, pull up these notes, and this is where we're going to get started from today. So yeah, we have a good bit of stuff to cover, which I think is pretty, honestly, relatively advanced, but pretty cool. And I think you can pick this stuff up even if you didn't attend the last session. But of course, if you want to fill in some gaps, as far as the web stuff goes, we're kind of moving away from any of the web kind of content stuff, and we're just focusing on making graphics. So we're still doing it in the web. We're just, we're just more focused on the graphics aspect. So we're going to learn some math. We're going to learn this graphics library called PTS. And it should be pretty exciting. Okay, so
before you move any further, I just want to let everybody know in Facebook land or on Zoom, if you missed the first session and want to watch the first session, it is on our library Facebook page and will at some point be on the library YouTube channel as well. So you can go to Facebook/NHFPL for the Facebook page, and I've squared on YouTube. It looks like we might be having some technical difficulties with the smartboard, but I can still see your screen. So I'm going to mute myself and try to fix the smartboard while you start.
Oh, great. Yeah. Yeah, the smartboard, just in case someone shows up in person. Okay. So yeah. But in case someone shows up, we can try to fix it. Yeah. Or they can just sit behind, or they can get on Zoom maybe or something like that. Yeah. Okay, so getting started here, these notes. Hi. Oh, cool. Okay, great. Okay, awesome. Yeah, you can just take a seat anywhere that you can see this. Do you have your computer? Oh, if you have a computer, yeah, okay. If you can help her get into Zoom. Yeah, it just keeps, this happened last week. It kept like disconnecting. Okay. But it could be the cable.
It could be the cable.
Could be the cable. I could try to get a little closer because there's another cable. Yeah, but then that happens. Yeah, it's kind of a funny. Oh, that's a good idea. Yeah. Let's try that. Okay. Yeah. Cool. And I don't need to see it, so it's just for you. Okay, great.
We'll just give this a second. Sorry to Facebook land and Zoom land.
Yeah, we should be up and running very shortly. I guess actually though, yeah, I can get you set up basically while this is going. So yeah, you're in the right place. We're doing computer graphics, so drawing stuff with code. If you want to go to this URL, I can.
The GitHub. It's GitHub, right?
Yeah. I was gonna say, I just realized it's a bit hard to give you the URL, but hopefully in a second. Yeah, that should be it.
It is.
Oh, okay, great. Oh, good. Yeah. Yeah, so I think the HDMI cable is just not good.
Okay, I think I have another.
Oh, nice. Okay.
It's not it. It's fine.
All right. So yeah, let me know once you find that web address. Oh, what's your name, by the way? Yvonne. Okay, cool.
I have a really short.
Yeah, I saw that one. I mean, I can try.
You want to move to this table?
I can do that. Yeah,
You move to this table.
sure.
And give you that.
Stand or sit. Okay. Yeah,
Here's
that's
the other end.
cool.
Technical difficulties are always fun.
Yeah. But not a problem. Does this one work?
Yeah, we're good. We're on.
Great. Okay, cool. So now you can see that.
Just make sure you hear your screen.
All right. On Zoom.
Yep.
Cool. Okay. All right. Okay, so Yvonne, if you want to go to this address just at the top here, github.com/PageSwanson and /NHFPL graphics. And it should look like this. Oh yeah, no, it doesn't matter, yeah. All right. And yeah, once you get situated there, you'll just go to this folder dated today. And then that's got our notes for this session. And you don't, yeah, you shouldn't need to copy the last part, because then you can just click once you're there. So it should look like this little folder setup. And then yeah, maybe I can see where you are. Oh, okay. Yeah, if you do PageSwanson GitHub, that'll probably find it. Yeah, perfect. That's just probably cool. Yeah, there it is. that first one. And then that was, yeah, you should see click repository top. Have to go there. Yeah, there it is. Okay, cool. All right, so once you get the repository loaded, we're just going to look through these notes first under that dated folder, 2022, May 12th. And yeah, that is where we are. Okay. So I'm going to go ahead and kind of start giving an overview. Basically, what we're doing is we're using the web browser to draw graphics. And the way we're going to do that is using JavaScript, which is code that's going to run in the browser. So we'll be able to write JavaScript code and then the browser will run that. This is really convenient because you don't need to like download any software or anything like that. But you will just download a file, which I'll show you how to do momentarily. And for those following along at home, yeah, you'll also be able to download this file. So in particular, what we're going to use today is a library, a JavaScript library called PTS, which is listed here at the top. So a library, in terms of code, is basically like a collection of pieces of code that someone else has written, or we could write as well. We could create a library. And it lets us basically just reference different bits of code that someone else has written very conveniently. So this library is a graphics library. And the point is that we can write our own code, which just uses the code provided by that library. And it's usually going to be a simplified way of interacting with something, with some deeper piece of code. So a good example of a library might be like something for audio, where if you want to play a sound on your computer with some code you write, you don't want to have to like write all of the code required to like play, like vibrate your speaker on your computer. That would be a lot of work. So you use a library, which will then figure out most of that for you. And then you just call one piece of code like play sound or something. So this is the advantage of a library. This library is going to let us basically do graphics with JavaScript to a pretty sophisticated degree that would just be a lot more complex to achieve just using JavaScript alone, with like the API provided by the browser, or the library provided by the browser. It's also going to make things, yeah, like somewhat easier to think about, like, but yeah, it'll be interesting. So there's this blog post in this link here. If you're interested in reading about the library, like why this person made the library the way they did. Yeah, it's in the notes. Yeah, all the links are in the notes. It's that third bullet. Yeah, so that's just if you're more interested in like why the library was made the way it is, because it's kind of a unique approach to graphics. But the person is a little bit strange, so take that with a grain of salt. But I think the library is cool. So what we need to do if we're going to build graphics in the web is we need a document. So we need to make basically a web page, but we're not going to like put it out in the World Wide Web. It's just going to be on our computer. And we can do that. We can point our browser basically to a document on our computer and it'll just load it as if it were on the internet. So that's what we're going to do first. So basically I linked the document that you need right here. This is the document from the last session though. So we're going to need to make some changes to it, which I've outlined right here. For the sake of time, I'm not going to worry too much about explaining the changes that need to be made. But the gist is basically we're going to include this library that I was talking about, the PTS library, which we're going to use, which we're going to do using this little piece of code here. And then an element of this document that I talked kind of extensively about last session, we're going to use in the same exact way. This is how we draw graphics. In JavaScript, it's called the canvas. If you want to learn more about the canvas, you can look at the last session, but it's not super important. It's just exactly what you would think. It's a canvas. It's basically a space where we can draw. That's what we're adding to our web document. And so we have to use the canvas a little bit differently with this library. And so that's what all this code is here. That's what this code is doing. So it's basically going to set up the library so that we can draw with the canvas. And then this stuff is kind of specific to the library, which I'll get into. So the first thing you want to do, if you want to follow along, you don't have to follow along, but if you want to, what you'll do is you just go up to this folder again, and you'll find this ptjs_canvas file. If you click that, you can download it by going to raw up at the top. So then it'll look like this. Once you click raw, like I clicked raw right here, and then it'll just look like this. And you can just right click this and save page as. And then for me, I'm just going to save it as .html like that. I'm just putting it in my downloads. So then it saves as an HTML file. And then what I can do is I can go to my downloads and find it. And I can drag it over to a browser tab and it'll open just like this. So it'll just open just like a web page. So this way, we're going to edit this file. We're going to add all of our code to this file. And then every time we make a change, we'll just reload it and then it'll show what we draw. So that's the gist. If you want to follow along, of course, you can also just watch and then do it later too. It's totally up to you. Yeah. Oh yeah, totally. Yeah, the big. Yeah, did you try clicking this at the, I may not have shown this part.
No, you did.
Okay. Oh, it did not let you go back to that folder?
No.
You could try going just back to the repository. Oh, good. Okay, great. Awesome. Yeah, unfortunately, you can't like download it very easily, but yeah, you have to go to open the file and then you can click raw. I think that's the easiest way. Yes. And just make sure when you save it, you have to save as and then add the .html at the end, because otherwise your browser will not open it. Okay, so in the meantime, so I've got mine open. So this is where I'm going to make all my changes for our drawing right in here. Okay. So once you've got the file going, what would be a good idea is to have some kind of editor. Do you have like a text editor that you can use?
So I'm just trying to get some
Gets-
kind of like basic.
Oh, totally.
It's not a day-to-day work thing.
Oh yeah, sure, yeah.
But you know, I saw when it was free. I'm like,
Yeah, yeah.
so
No, that's yeah, that's great.
I know nothing.
Okay, all right. Okay. Well, this is cool because I mean I have all of the code that we're going to use, so you can just copy paste it in. That's totally fine, and you can just see what it does. So, okay, but what you might, so on your computer, there's this program. It's called Notepad. if you press the Windows key on your keyboard, like with the little Windows sign, like the little Windows icon, is there a key like that on there? There should be on the bottom left, your keyboard. Yep, that's it. Yep. So click that, and then it should pop up a little search. Do you see that?
So I just click on
Mhm.
that, or do I click on?
Oh yeah, you just press the key. Just press the key. Yeah. And it should pop up like a little search or something. Okay, so type Notepad. Yeah, that will guide you to an application called Notepad. And you can open that file that you downloaded. You can open that inside of Notepad. It's not the best text editor for writing code, but it totally works.
Is it supposed to look like that?
Let's see. Oh, I see. You found that's like a different application. Yeah, try. Oh. Yeah. So we. Oh, I see what it did. It like was like you don't have to update it. You just want.
I saw that, but I wasn't sure.
Oh yeah, no,
It's
no,
like,
this
I
is it.
just-
No, that's okay. Yeah, I think it's searched online. I mean, that's a really good one, by the way. Like that one works great. But this one is very, very basic. It's not very sophisticated at all, but it'll do the job. So then just go to File at the top left. Yeah, perfect. And then you can just say Open. And then you can just open that download that you just had earlier. Or like wherever you, oh, I see, it's filtering. Just click that little drop down on the right. This one. Yeah. Click that. And then just do all files. Okay, perfect. So there it is. So there's that one. Yeah, go ahead and open that one. Okay, so basically this is how you're going to edit, you're going to add the code in from the notes.
Okay.
So whenever I copy paste something in, you'll just find that same place in the file, and then you'll want to save it. You can just do Control S to save, just like a Word document or something. And then in your browser, you will just reload that tab, and it should. So we'll try it out. We're about to make the
So
change.
most of it, is it okay if I watch?
Yeah. Oh no, totally, absolutely. Yeah. Yeah, whatever works best for you. Yeah. But that will, like, if you want to do it later, you know exactly now how to edit and stuff. So, okay. So, okay.
So before we move forward, so
Uh-huh.
when I did
Mhm.
HTML and I brought it over here, this ended up for my computer, it ended up just showing up as a blank.
Yeah, does it look like this? No, that's great. You're good to go. Yeah, we will put something in there, but yes, in due time for sure. So this part is just basically talking about this part of the notes. I'm just talking about kind of like what we need to do to use the library with this big blank white space, which is actually the canvas. So it's not super important, but I do want to talk about these three things right here. So with this library, which you can think of as just basically like, this is how we're going to approach drawing with code. So there's these three kind of concepts that this library uses for you to draw. So there's the idea of a space. So a space is like the area that we have to draw. So that's what you should think of when you see the word space. So you'll see that come up in the code. That's what that kind of means. Then you have the form. So the form, I don't think it was the best choice of word, but it makes some sense. Basically, the form is like putting everything that we've created in space onto paper with like we're drawing it basically. So whenever you see form, it means like, okay, we're going to draw the stuff we put in space. That's kind of the idea there. And then finally, there's points. So points are found in space, and then you can use the form to draw the points. And typically, we're not necessarily drawing the points, we're drawing like using the points. So we're thinking of a point. I'll talk in more detail about that in a second. I'm going to reference some colors in some of this code, and I did so last session too. If you end up reading those notes, I didn't really explain like the way color works in particular for JavaScript in the web, but also generally when you do computer graphics, the way color works is using what's called an Rgb coding. So I have this link. I'm not going to spend a bunch of time talking about this, but you can read this Wikipedia page if you're interested. This is basically how computers understand color. So it's called Rgb because it consists of red, green, and blue codings. And this is called an additive color model because essentially to make any other color, what you do is you take a little bit of red, a little bit of green, and a little bit of blue, and you add some varying amounts of those together, and then you get the color you want. So if we want to talk about black, for example, in Rgb, the way I would describe that is by saying 0, 0, 0. So 0 red, 0 green, 0 blue. And that is black. Conversely, white would be the opposite. So it would be the max value of red, green, and blue. And that would give us white. That's basically what you need to know as far as how the color is coded. Now, the other part of this is that I'm going to be using this special type of encoding, which is just a way of representing a number. I'm not going to use digits, which would be numbers 0 to 10 or 0 through 9. This is going to be using something called hexadecimal.
Book library will be closing in 1 hour.
Thank you.
The computers will shut down in 45 minutes.
Great. No, that's okay. So hex coding is just an alternative way to represent numbers. It allows you to represent numbers 0 through 15 with 1 digit. So I don't need 2 digits to represent 10, 11, 12, 13, 14, 15. I can use just 1 digit. And the way that works is basically you say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you start with the letter A. It's just kind of a weird way of representing digits, but it comes up with color all the time because you can represent a lot of color values very concisely. It's not super important, but that's just what you're going to see. You're going to see some hexadecimal coding for the colors. So just so that's not confusing, that's what that is. And of course, that's all kind of described on this Wikipedia page, so it's not too bad. Okay, the next part for context that we'll need to start understanding some of the basic examples, and hopefully don't be super intimidated by this because you can do all this stuff without knowing linear algebra. But yeah, but there's some basic ideas that are helpful to understand, which we will visualize with all these examples. So it's not a super big deal. However, if you want to like understand the background, there's these links that I provided, which do pretty well at, it's more of like an approach like from the graphics perspective. I mean, they do use a lot of math, but it's like very visual. So if you're thinking about the graphics and then reading this stuff, it's not so bad. Like it does make sense. They relate it to something you're seeing on the screen. So it makes it a bit easier. This one is really dense, this link. This is the second link, but this first one is, I think, this first one is really nice. you could probably read like just up to maybe like here, just before matrices. And that would be you'd have like a pretty good understanding of basic linear algebra. Oh, cool. Oh, you're familiar. Oh, great. Well, then that's really good. So yeah, if you're okay, great. Yeah, if you're familiar with vectors, then you're in a really good place. That's pretty much everything goes from there. So everything is kind of working with this concept of vectors. So just for the stream, like I said, there's a lot of information, but with limited math background, even using this library, that's kind of the nice thing about the library is it does a lot of that stuff for you. You just have to know the concept that you're looking for. So like making lines, curves, arcs, you can do all that stuff and it will handle the math underneath that. So it's really nice. You just have to know what you're trying to do. Yeah, so it abstracts this away for us, this library, and then we can make some pretty sophisticated stuff. But with some examples coupled, we can kind of go through the fundamentals because these are all things that are necessary to understand graphics. So graphics, for the most part, happen in like a 2D space or a 3D space. And so what we're doing when we're coding with graphics is we're trying to map that space and then write code that has functions or ways of programmatically like describing that space. So that's kind of what we're doing. You're basically asking the computer you're describing to the computer what this space looks like. So it's kind of a challenge. So there's some conventions around how you do that. So the first one I want to talk about, this is like the most basic aspect of linear algebra, but of graphics usually, is a point. So we need to be really clear about what a point is. A point is basically a place within some dimension. So you can have a one-dimensional point, you could have a two-dimensional, three-dimensional point, but it's very important to note that a point like isn't anything in particular, it's just a place. It's important not to think of it like it takes up some kind of space mathematically, because it does not. It's just a place, it's a position. So that's how we're going to think of it as well with this graphics library. Usually to figure out the dimension where the point lives, it's kind of implied by the description of the point. So like if I say a point at 1, 2, that would usually imply a point at x equals 1 and y equals 2. So it's a two-dimensional, a point in a two-dimensional plane. So thankfully, we can illustrate the way this works with our graphics library with this library utility called PT. So the code, the little piece of code from the library we're going to use it's called PT, and it's a point. But just to keep in mind, this is a lot more than just a place in space. What this code does, it lets us do a bunch of things, but it's going to help us visualize a point in space. So here's what I'm going to do. I'm just going to copy this. You can, if you're in the notes, what you can do is just use this top right-hand function. But of course, if you're just following along, that's fine too. So you can copy this. And what I'm going to do is I have a text editor here called Visual Studio Code, which is really nice for getting started with. It's really, really good text editor. It's pretty friendly. And then I'm going to go right between this line 16, get form, and just above this line 20, play once, right here. So basically, I'm going to paste the code right in, and it pasted a little bit weird, but that's not a problem. So, okay, so I pasted this code in. I'm going to save it. And before I even describe what this code does, I'm just going to make sure it works. So I'm going to go back to and I'm going to close this linear algebra and other links. I'm going to go back to this page that I have saved on my computer. I'm going to reload it. And we should see the results of this code change. So basically just added this little dot. Yeah, so this is the way you can kind of conceive of a point in space. I think most people probably do when they talk about points in math and stuff. You think of like a dot or something like that. So that works pretty conveniently for us. So, okay, this is pretty convenient to be able to think of points, but like, how did we do this? What is the code that we had to write in order to get to this? So can you see that okay? Okay, great. So the first part of this, I already kind of talked about. This is just basically how we got to interact with the library. And I mentioned this idea of space, which is the canvas. I mentioned the colors. So this is BG color, background color. So this is the red digit, the green digit, and the blue digit. So it's the max value for each of those. So it's going to be white. So that's how we get the white background. And then I'm getting the form. You have to get it from the space with this library. That doesn't matter. The point is that I guess it kind of makes sense because the idea is that the form, which is like the pencil that I described, it's applied to that space. So anytime you use the form, it's referencing the space to draw in it. That's kind of the idea. Okay, but this is the meat of what we're doing graphics wise. So we're doing two things with this piece of code. Everything we're going to do in all of these examples, we're going to do inside of this little indentation here, this block called space.add. The idea is that we're adding to the space. So everything we want to add to the space, we're going to do it inside of here. I'm splitting each of the sections for the most part into two blocks, sort of. Anything you see with these dashes, these are comments. So they don't actually do anything. So this is just plain English. So everything you see here, I'm just describing kind of what's going on. Anything that's colored, though, that doesn't have these dashes, that's actual code. So the first thing that we do is we set up a point. So in code, the way we're doing this is that little PT keyword that I mentioned. This is from the library. And what I'm saying is I would like a new point at 200, 200. The reason I chose 200 is because if you look at the rest of the document, I made the canvas 600 by 600 pixels. So I just picked somewhere in there. I could change it. Exactly, yeah, exactly. So this is the X dimension, and this would be the Y dimension. So that convention is like probably what you're used to from math class, and also that's how it's going to be done in code too. One thing I'll point out that I think maybe just speaking of convention does deviate a little bit, but is the way you do it in graphics. So from school, you're probably used to X from left to right, and then Y, you know, up and down. One thing that differentiates in graphics, so I'll reload this. So I moved the point to 400, 400. But if I change this Y dimension, let's make it 100. You'll notice probably something that isn't necessarily intuitive. So the point moved like up, even though I lowered this number. That's because in computer graphics, virtually all, I mean, yeah, pretty much every computer graphics application, like at all, Y is always 0 starting from the top. So that's just something you just got to kind of like, if you get into computer graphics and start coding with that, it just always starts from the top as 0. So that's just the only weird part, but everything else is pretty much what you'd expect. So, okay, so we made this point, but that didn't draw the point. That just set it up in the data that our code is using. So it made this variable. This variable is basically storing the structure that defines this point. So then what I want to do is I want to give the details of how to draw the point in space to this form. So all of this is from the library. I don't like know it personally. I had to like look all this stuff up as I went along. So that's totally fine if it's like, it seems very arbitrary, because it is. It's totally arbitrary. It's just the person that made the library decided that this like looked nice and they liked the way that it worked. So